Right, this is the group video for the new Excel papers, the last sort of papers we're going through before your real exams. So hopefully you find these videos really useful. And like I said, these papers have probably been written around about the same time your actual exams have been written by the same people. So they're very, really useful in terms of getting a sense of what they're likely to be asking you, how they're going to be asking you it. Okay, so if you're finding these difficult, these videos will be really valuable to you. Okay, the first question is very straightforward though. It is not hidden away. It's just a basic ratio division. The whole thing with ratio division is that you need to know what one part is worth. Okay, so it's all about finding one part. Okay, we know what one part of your ratio is worth, you can figure anything out. At the moment, we have 7 parts because I know we have 2 on the left, 5 on the right. So we have 7 parts. To find one part, I'll need to divide by 7. So divide our money by 7. 28 divided by 7 is 4, so that'll be 40. So each part is worth £40. Ali gets 2 parts, Beth gets 5 parts, so we're going to times both of those by 40 to get 80 to 200. So that's how much each of them gets. Okay, so very standard with ratio. Finding one part is the important feature. Okay, this one worth 5 marks relies on very nice straightforward maths, so hopefully you understand what's going on. And it's understanding the key information that they're giving you. The key information that you can see, you've got parallel straight lines and you've got isosceles triangle. Okay, or an isosceles triangle. That's rubbish, so it's in the bin. So with parallel straight lines, we're thinking alternate angles, corresponding angles, co-interior angles. With isosceles triangles, we're thinking that the base angles of that will be the same. So there are starting points that we're going to use. So I can see the triangle they're talking about, so I'm just going to tell myself that these two are going to be the same. And what I'm going to do is write down base angles in an isosceles triangle are equal, because that'll feature. So I'm getting that down now, okay, so I'm going to use that. So I've got many options. If I can find this angle, or these angles here, at least I'm coming towards finding X. So let me just find the missing angles in this triangle. So the first thing I can do is to say that this is going to be 180 degrees in a straight line. Okay, so I know angle ABE equals 180 take away 142, because angles on a straight line equal 180 degrees. So now that ABE equals 38. So I know that's 38. Okay, so that's 38 degrees. And now I can use that to find these base angles. So I know that the base angles are going to be 180 take away 38, which is 142 as we had it earlier. And if I halve that, I know that the base angles are going to be 71 degrees. Okay, and I've justified why that is. It's probably more sensible to write this as you're doing it, so when I've used this calculation here, it's better to have written this after, to be honest. And the next thing is to nail this X. So there's a few ways you can say that this angle and this angle here, so ABE equals BEF, because they're alternate, and then do angles on a straight line. But you can see, if you can see this zigzag this way, you can see that 71 ABE equals DEA, because they're alternate angles. So I'm going to write it down. So BAE equals, I'll do AED, it doesn't matter which way around you do it, because alternate angles are equal. So that is going to be 71 degrees. Okay, and I've got everything there. 5 marks, nice and straightforward. And it's just remembering isosceles triangles that the base angles, look at this diagram, the base angles are going to be on the line without the dash. Okay, it's not the way it's drawn, it's where these dashes are. So if those lines are there, this one is going to be the base line, so the base angles are there. Okay, so it's very important to remember that. The perimeter of a square, so obviously it's not a square, so they're getting you to imagine a square, has the same length as the perimeter of this triangle. All measurements are in centimetres. Find an expression in terms of x for the length of the sides of the square. Give your answer in the simplest form. So this perimeter, and remember that perimeter is when you add all the sides together, is going to be the same as this imaginary square. Okay? So that's the building blocks we've got. So first of all, I'm going to find the perimeter and show the examiner that I know that I add the sides together. Some people multiplied and were spending ages doing a triple bracket expansion. Okay, but it says perimeter, so add. That gives me 2x, 5x, 5x, that's 12x. 3 add 3 is 6, take away 2 is 4. So that's the expression for the perimeter of the triangle. If it's going to be a square, if that's the same for this square, all 4 sides are the same and they make 12x plus 4. So 4 things are the same. So what I'm going to do to this expression now is just divide it by 4. 12x divided by 4 is 3x. 4 divided by 1 is, 4 is 1. I was thinking about the answer. So the expression for the length of the side of the square is 3x plus 1. Okay. Showing you're working out is very important to get the adding and the dividing bit to do that part there. Okay. Nice, straightforward. The next one, 5 marks. So it's about clarity of your written work. So they want to see what's going on, so they know what's happening. So the diagram shows a swimming pool. The swimming pool is in the shape of a prism. So we know that the volume of a prism is the area of the cross section times by the length. So it's area times by length. So I know that to start off with. The pool is going to be filled up with water at a rate of 5 litres per second. So every second this is going to fill up with 5 litres of water and it's going to fill up. Jeremy has 10 hours to fill the swimming pool, and we know that 1 metre cubed is 1,000 litres. He must completely fill the swimming pool in 10 hours. Will he completely fill the pool in 10 hours? And we've got to prove yes or no. Okay? So that's what we're going to do. So the first thing we're going to do is find the volume of this in metres cubed. We're then going to turn the metres cubed into litres, so we know how many litres this swimming pool contains. We're then going to figure out, if we know how many litres are, we're going to figure out how long it would take to fill it up if it was 5 litres per second. And then we're going to see how many seconds are in 10 hours to see if there's enough seconds in 10 hours to fill it up properly. So I'm going to do the volume now. The volume is the cross-section area, so that's this shape at the front. Okay, it's all this. Look for a decent felt tip. It's not going to be great. I reckon this is dried out. So it's the area of this. Oh no. Times by the length, which is actually the depth in this one. So it's how far back it goes there. And that'll give me the volume. So that's what I'm going to go for first. So the volume, I'm going to do the area. So I'm going to break this shape into 2 shapes. So the rectangle and that triangle. We know this rectangle is 15 long and 1 down. That leaves the height of this triangle to be 2, because it's all 3 there, look, so we can figure that out. And if this has come across 10, I know that this base of the triangle is 5. Okay, so I'm going to find the area. So the area of the rectangle is 15 times 1. Add the base, add the area of that triangle, which is base times height divided by 2. And then that will be times by, when I add these together, it'll give me this pink section here. I can times by the depth of this prism, the length of this prism, which is 10. So that's what I'm going to do. So I'm going to work out my brackets first. So 15 for that part. 5 times 2 divided by 2, pretty much they cancel out. But if you did do it properly, 5 times 2 is 10, divided by 2 is 5. So we've got that. Okay, so remember this is the area of that shape. We'll times that by 10. So that's 20 is the area times by 10. So we know the volume of the shape is 200 meters cubed. Okay, so messed it up a little bit with these big brackets, make it look a bit scruffy, but they can still see that I'm finding the volume first, so I've done that. Now that's just the volume in terms of meters cubed, so how big it's going to be. It's not as it is in litres, so it doesn't tell you what the liquid amount is going to be. But we get this here, and we know that each metre cubed is 1,000 litres. So I'm going to convert my volume into capacity, into a liquid, by times it by 1,000, because we know each metre cubed is 1,000 of them. So that's what I'm going to do. So I've got 200,000 litres in this pool. That's how much water's in there, or needs to go in there. So I've done that. That's the next phase. So I have to convert it into litres, because I know that 5 litres fill up every second. So what I can do now is decide how long it's going to take 200,000 litres to drip out, or to fill up. So what I'm going to do is I'm going to divide by 5. Or I'm going to do it separate. I'm going to do it over here. So 200,000 divided by 5 will tell me how many seconds it's going to take. So you could just think about it clearly. And if you can't divide, use your bus stop method. Look, it doesn't matter that it's a big number. So 5 into 2 goes 0, carry 2. 5 into 20 is 4, and the rest is 0. So we've got 40,000. So it's going to take 40,000 seconds to fill up this pool. Okay, and what I'm going to do now is turn 10 hours into seconds and see if it actually makes 40,000 or not. If it's less than 40,000, you won't fill up the pool. If it's more, you're going to be able to fill it up in time. Okay, so we're going to take the 10 hours. We're going to times it by 60 to turn that into minutes. So that's the minutes part happening. And we're going to times that by 60 to turn it to seconds. Okay, so when you've got zeros in your calculations, ignore them. 1 times 6 is 6, times 6 is 36. And now include the zeros, there was 3 of them. So we're only going to be filling up for 36,000 seconds. To do it properly, to fill it up, it needs 40,000 seconds. So we have proved that they're not going to be able to do it properly, they're not going to fill it up, so no. You have to respond. It doesn't have to be a massive response, and that'll do for me. The working out demonstrates what's going on. Okay, so lots to that question, and lots of things to get right in the right order. But there you go, that's it. Okay. Right, the next one. It takes 12 men 5 days to do a job. How many days will it take 3 men to do the same job? Okay, so I want to think about the total amount of days people are working for, and then see how long it's going to take 3 people to do that. So if 12 men are doing 5 days each, in total there'll be 60 days being worked to do this job. We now only have 3 people, so we want to know how many days, and when I say how many, I'm telling you what maths is going there. How many days means I'm going to divide by 3. So we've got 60 days, and there's only going to be 3 people doing it now. I'm going to divide by 3. That means there's going to be 20 days in total it's going to take for 3 men to do the same job as 5. Okay, that's that one. Nice and straightforward. Find the total amount of days, or total amount of working hours, or whatever it may be for these proportional ones. And there you go. This is only true though if all the people are working at the same rate. So if I get 5 people who are quite lazy, and then I get 3 people to do the job that are really efficient, really like enthusiastic, they might do it quicker. So it's assuming that these people work at the same rate. So everyone works at the same rate. Okay, that is the assumption we make. And you might have the other way around. You might assume that these 3 people are going to work at the same rate, but they're really slow. So you thought it was going to take 20 days, but your project's taking 30 days because they're working too slow. How would that be affected if your assumption is not correct? So I'm going to just give it a little bit of detail, so I don't just say it might be too small, too big. I'm going to say if the workers are too slow, if the workers are slower, it will take longer. And the reason is I'm just demonstrating I understand the relationship between how fast they work and how long the job is going to take. I'm not just saying it takes longer or less. It's if they're slower, the job's going to take longer. Or if they're faster, the job's going to take less time. So it's making sure that whoever's reading my work knows I understand the relationship that's going on here. Graham has a fair 6-sided dice and a fair blue 8-sided dice. That's the numbers on the red dice, that's the numbers on the blue dice. It being fair means it's not going to land on any other number more than once, or it's not going to favour a number, it's just an accurate dice. So landing on a 6, not landing on a 6, that's the options we've got for both dice, and in the end we need to figure out the probability that you're not going to hit a 6 twice. So on the first dice is the red dice, so we'll just focus on these ones. Okay, not getting landing on a 6 is 1 out of 6 options. So therefore, without even looking at what numbers are on the dice, here look, I can just know that if that's 1 out of 6, that's got to be 5 out of 6, so I know that. Now we're going on to the blue dice. So this whole section here is about the blue dice. This is the red dice done. It doesn't interact with the blue dice. They are separate. So whatever's going on here, it does not affect this set of values here. Sometimes it will, if they're talking about, I know, bags in a counters in a bag. You might add one to the new bag or something like that, something different. But this does not affect it. So landing on a 6 on the blue dice is 1 out of 8. So not landing on it is 7 out of 8. And this is just the same dice happening again. So it's the same thing. So 1 out of 8 and 7 out of 8. You will write down these fractions here. So 1 out of 6 times 1 out of 8. 1 out of 6 times 7 out of 8. You will do this. 5 out of 6 times 1 out of 8. And 5 out of 6 times 7 out of 8. You are showing your examiner you know you must be multiplying to combine these fractions. And for yourself, this bit is nice because you can check if you're doing it right. So I've got 1 out of 48. I've got 7 out of 48. Because when I multiply fractions, tops times tops, bottoms times bottoms. So I'm going to do 48 along all of these now. 5 out of 48 and 35 out of 48. So they're all the possible probabilities. And I know I've already got one here of these marks without even reading this part at the bottom. I know I've got one. And if I add 1, 7 is 8. 8 add 5 is 13. 13 add 35 is 48. I know my probabilities are right as well. So that's a good thing. Work out the probability that neither dice will land on a 6. We've got one for multiplying already. So it's just picking the right values. And if there's more than one option, adding them up. So no 6, no 6. There's only one option, which is that. So the only answer is 35 out of 48. You don't have to simplify on tree diagrams. Okay, so don't try to. Just leave it. Okay. If there was more than one option, let's say you had a possibility of getting a 6 on either dice, you would have these two. So you'd add the tops of these fractions to make that it's a probability. Okay, so it's nice and straightforward. If these come up, I'm looking for 4 marks for most of you. Okay. Right. Quadratic nth terms. Okay, new to the exam, but there's always like an easy mark. And the easy mark is working out the gaps, the differences. So that's what I'm going to do. I've already established that this is going up in 2, so I'm going to save myself some time and just write these going up in 2s. I know that these gaps are going to be 2. I've just nailed the mark. I've proved that this is going to be a quadratic one because it's got the gaps of 2. This is where the technique comes in then. So we take that second difference and we divide it by 2. And that reveals which type of square numbers we're going to use. We're going to use the 1n squareds. So just the n squareds. The natural square numbers. And they are 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. You don't need many of these. 4 will do it. But that sequence clearly is not this sequence. So n squared as a rule, it's a good start, but it's not the rule. It doesn't give us the sequence. So we're going to put our sequence above it and take it away to see what the difference is. So in this one, it's just 2 all the way along. Sometimes it's 2, 5, 8, and so on. So you have to do another nth term, but a basic one, and that's just written on the end. But this time, just because it's a number all the way, you just write it on the end of the roll. So it's the square numbers add 2, and that's the nth term. If you ruin this, but you do the 50th of your rule, you still should get the next mark. So n squared plus 2 is the generating, that's the generator really, the function machine. 50's got to go into it, so 50 changes the n. So it's going to be 50 times 50. 5 times 5 is 25 with 2 zeros. And then we add the 2. Okay, so 2, 5, 2. Okay, nice and straightforward. Okay. And like I said, if you don't understand this and you ruin it, make something up to use it. Because you need to get credit for substituting the 50 into a rule. Okay, that's the separate understanding that you're trying to demonstrate there. So you have to play the game a little bit. Okay, multiplying fractions. Tops times tops, bottoms times bottoms. Problem, you've got mixed numbers there, so you haven't just got tops and bottoms, you've got a mixture. So we're going to have to change that now. So we're going to change 2 and 3/4 into a top heavy fraction. So we're going to do 2 times 4. So it's 2 lots of 4s with 3 already on the top. And then we're going to change this one. So 3 times 5 at the top gives me 11/4 and gives me 16. Is that right? I'm just looking at it now. 16/5. He's just double checking. It's because I did one with the class today and it was a different one. So my brain's thinking about that question instead of this question. I think that's right. So 11/4 times 16/5. Now you can be sneaky right now and cross cancel. So we could cancel out these 4s, okay, and make this over 1 and make this over 4. One of the students in my class did that, so well done. Your name begins with B. But you can just do tops times tops and bottoms times bottoms, okay. If you can't multiply in your head, write it out, okay. So you could do 10 times 16 is 160. 1 times 16 is 16. So it's going to be 176/20. That can just go there. If you can convert it into a mixed number, do so. If you can't, leave it alone. Leave it like that. Because that's accurate, that's the one. If we did cross cancel, that means look diagonally and see a common number, it would have made things a bit easier, and that would give us 44/5. And then when we convert that into a mixed number, 5 goes into 40 8 times with 4 left over. That gives us a simplified answer. That's why we encourage the cross cancelling. But that might throw you off if you're not sure what's going on. Okay, that's the bell, so I'm going to have to go on duty. So I'll stop this one now.